Welcome back to Introduction to Programming using C++. Same old host, it's Alex Louie. Today we're going to go over simple logic operators. The logic operators consist of the AND, the NOT, and the OR. Now, in order for you to understand the behavior of these operators, it's helpful, I think, to look at a truth table. So truth table gives you all the possible outcomes, assuming that you have the inputs coming in with the outcome fixed outcome. So when you use an AND operator, you're always going to have two inputs, A and B. Okay. Depending on the value of these inputs, you're going to get a Boolean result. Now, if you remember what I talked about, Boolean, you either have a true or a false. Okay. So in order for you to get a Boolean result, you really could only have Boolean inputs. And that's what I have labeled out here. So for input A, 1, we're assuming that is true. And if you want to use an input of false, then you would use a 0. So for all the possible combinations of two inputs, this truth table tells you what the result will be if you feed it into an AND operator. Let's go through the first example. If I do 1 and 1, then your result will be 1. Okay. Now, I'm not getting that as a calculation. It's just a fixed truth. That's why it's called a truth table, because it's just a fixed truth. It's rules based on this AND operator. It's very important to realize that there are really no calculations that we're performing to get this 1. We are just following the truth table for the AND operator. Okay. Now, if I feed it a 1 and a 0 to the AND, then I'm going to get a 0. I'm going to get a false. If I feed it a 0 and a 1, then I'm going to get a 0. And then if I feed it a 0 and a 0, then I'm going to get a 0, which is false. The only time that the AND operator will give you a true result is when both inputs are going to be true. Now let's look at the OR operator. The OR operator, same thing. You're going to have two inputs and one fixed output. And the rules go where if at least one input is true, then the result is going to be true. Now let's go over these. 1 or 1 is going to give you true. 1 or false is actually going to give you true. If you notice the difference between and or, when you have this row here, in the AND operator, you're always going to get a false, but in the OR, you're going to get a true. And then same thing for the next result, you're going to have 0 or 1, which is going to give you 1, which is true. And then 0 or 0 will give you false. So it's important to remember again that and in OR, you're going to have the same amount of inputs, okay? But you're always going to have a fixed output depending on the inputs, and that's why this is called a truth table. Now, why am I showing you this? I'm showing you this because once we use these in C++, you have to remember the result of what you're getting so that you validate what you see on the compiler. Okay. Now, in the C++, the AND and the OR operator, I'm going to show you in a little bit, they are used as symbols. So AND will give you a ampersand, and OR is going to be two pipe delimited characters. Then the last logical operator is a NOT. And the NOT is very simple. You're only going to have one input, and what it's going to return, or what the result is going to be the inverse of what your inputting. In this particular case, if I take the inverse of 1, it's going to give me a 0. The inverse of true is going to give me a false, and the inverse of false is going to give me a true. Now, knowing the rules of these logical operators will give us a better understanding of how it's going to react in the actual compiler. And I've put up a few examples. So for example, okay, as you know, again, these all return a Boolean result, which means that I can store that result in an integer or a Boolean variable. Okay, it's pretty much the same thing. So if we start with not, and we say not 1, which really is not true, this is going to give me a false. Okay, so actually let me comment this out. And I run this. So the not result is going to give me a 0 false. This is a 0. Why? Because I'm taking the not, the inverse of this 1, and I'm storing actually the result of that into my result variable. Okay, so remember, it always gives you the inverse of that. Okay, now the other thing I want to explain to you is that we're doing the simplest case right now. It's going to get a bit more complex when we start mixing our logical and relational operators. But it's the same idea. So my point here is that first we need to learn the fundamentals of how they behave. If you don't know the fundamentals, then mixing them is going to confuse you. Okay, so if you don't understand relational operators and Boolean, go back to my lessons on those. Okay, so we've done the not. Now let's do the and. So how does and look? Actually, let me label these. Oops. So the and operator has two ampersands. So what I'm doing is I'm taking input A and input B. Input A has a value of true, true, and I'm storing the result in my result variable. And again, I'm only showing these two expressions so that you know that I can then store the result in an integer or a Boolean. That's the only reason why I'm doing that. So this should return or give us a value of 1. 1 and 1 will give us 1. And there you go. And result 1. Now if we play with this and we say 1 and 0, do these, then what do you think our result is going to be if you have a true and a false? Well, very easy. We look up into our truth table, and if we have a true and a false, what should we get? We should get a false. Okay. So if I run this again, that's what we get. We get a false. Okay. So the and, the left, so this is called the left operand and the right operand. Depending on what these are, you're always going to get a fixed result depending on the truth table value. So if you play with these, you should be able to match it up to your truth table. Now, let's do the OR. If I do the OR, let's try this. So the OR are two pipe delimited characters. Okay, two pipe delimited, or two pipe characters. The pipe character should be above your shift key. So what you would do is press shift and then type in the pipe character. So now when I look at the OR, okay, we are going to take this, which is a true. 1 or false will give you 1, right? Because according to our truth table, 1 or 0 is going to give you 1. And if I use these interchangeably, when I say 1 or false, it's really 1 or 0. So true or false will give you true. Okay, so if I run this, it's going to give me true. Okay, now if I do false or false, then according to a truth table, it's going to give us false. And that's what the compiler does. Okay. So very easy concept, very easy operators. And now we know the results of our logical operators. And I think now we would be ready to evaluate expressions using a mix of logical and relation. So in the next lesson, that's what I'm going to do. I will teach you about mixing the expressions with logical and relational operators. Along with, you can even mix mathematical operators with this. Okay, so thanks for listening and watching, and I hope to see you on the next video. Again, if you have any questions, you can always email me at parttimeadjunct@gmail.com. Thanks very much.